somewhere above you right now. There's a beam of light that left a star before dinosaurs even existed. And here's the thing. As far as that light is concerned, no time has passed. Not a second. Not a fraction of a second. Zero. I'm not exaggerating for effect here. This isn't "it feels like no time passed." For light, there's no such thing as time passing at all. And once you get why, you're not going to look at sunlight the same way again. Because honestly, the weirdest part of this isn't even about light. It's about what now actually means for you. So let's start with the part you might already sort of know. Einstein figured out that time doesn't tick at the same speed for everyone. It runs slower for things moving faster. And I want to be clear. This isn't a fun hypothetical. It's been measured. Clocks on airplanes run very slightly behind clocks on the ground. GPS satellites literally have to correct for this every day, or your phone's location would drift off within hours. Faster you move, slower time goes for you, compared to someone standing still. Already kind of strange. But stick with me, because we're about to push this to the edge of what it can even mean. What happens when something isn't just moving fast, but moving at the fastest speed that exists, period? Light moves at the speed of light. Yeah, obviously. But here's the part almost nobody actually stops to sit with. The math that describes time slowing down doesn't just slow down more and more as you get close to that speed. It breaks completely. Once you're actually at the speed of light, the equations stop making sense in the normal way. At that speed, time doesn't crawl. It stops. Zero elapsed time. Doesn't matter how far the light travels or how long that trip looks like from our side. So picture a single photon, one particle of light, coming from a star 4 billion light years away. From here, from Earth, watching it happen, that light has been traveling for 4 billion years to reach us. But from the photon's own point of view, if point of view even means anything for a photon, none of that time passed. Not 4 billion years, not 4 billion seconds. The moment it left the star and the moment it hits your eye happen for the light at the exact same instant. It left and arrived at the same time. That whole 4 billion year trip, that only exists on our end. And here's where it stops being just a cool fact about light, because you're not as separate from this as it feels like you are. You're moving through space-time too. Right now, even sitting completely still, you're not actually still. You're moving through time about as fast as a slow-moving thing possibly can. And the faster you move through space, the slower you move through time. Flip side's true too. The more still you are, the faster you're technically aging. Which means the speed at which you experience your own life, your thoughts, your heartbeat, how fast you're aging, isn't some fixed universal rate. It depends on how fast you happen to be moving. Somebody on a plane right now is aging very slightly, slower than someone on the ground. The gap is way too small to ever notice in a lifetime. But it's real. It's been measured. So if a photon experiences literally nothing, zero time, and you experience time at a rate that depends on how fast you're moving, what does now even mean? Here's the part that kind of wrecks the whole idea. Two people standing a few feet apart, both totally still relative to each other. They agree on now. Fine. But the second either one of them starts moving, even a little, their now starts drifting out of sync with the other person's. Not by much. You'd never notice it at normal speeds, but it's happening. And it means there's no single universal now that everyone's sharing. There's your now. There's the now of someone across the planet. And there's the now of a photon that, if it experiences anything at all, thinks its entire 4 billion year trip took no time whatsoever. Now isn't some fixed line running through the universe that we're all standing on together. It's personal. It depends on how fast you're moving. And there's no version of now that's more correct than anyone else's, which means the sunlight on your skin right now arrived, from its own perspective, the same instant it left the sun. But from your side, it took a little over 8 minutes. Both of those are true. Neither one wins. There's no tiebreaker. You've probably gone your whole life assuming everyone's sharing one present moment together. You're not. There's just your version of now moving at whatever pace it's moving, not faster or slower than it's supposed to be because there was never a correct speed to begin with. Next time you're outside and the sun hits your face, remember that. That light left the sun 8 minutes ago as far as you're concerned. As far as the light's concerned, it never left at all. If you want more videos like this, stuff that quietly messes with how you see things you thought were simple, subscribe. There's a lot more like this coming.